Hi everyone, today we're going to demo our final project. So the goal of our project is to create a web service that gives the list of foods that have the highest proportion for certain nutrient. And the logic behind our application is that we first import the data into Azure Databricks and then build the pipeline on Databricks. And then we use Flask for both backend and front end, which it queries the data from Azure, and Azure will return the result to Flask. And Azure and Flask are packed into a Docker container, and every time a user clicks a button on the website, they'll send a request to the Docker and return the result to the users.
So our app is called Nutrition Guide. It's a dynamic auto-scaling web application that interfaces with Databricks pipeline utilizing Docker for containerization and Azure App Service and Flask for deployment and management. So as here we can see with the app, when users select their desired nutrient from a drop-down menu in the web application, for example, as showing here, and then we click Get Info, then a query will be run on the back end in our database to identify the top 10 food that are highest among the chosen nutrient. And as we can see, the result display here is the top 10 food. For this web application, we have used a database from United States Department of Agriculture Food Composition Database, and the more info is linked here and with its supplement documentation. And here is the dependency installation setup we've been initialized in this project. So including in things like Flask, Databricks, SQL connector, and then to make sure our web runs smoothly. And I will pass to my teammate Tina.
So during our development process, we integrated advanced AI pair programming tools such as GitHub Copilot and AWS Code Whisper to enhance our coding efficiency and accuracy. So for instance, we use these AI programming tools to adapt our existing ETL queries, originally tailored for SQLite, into a format suitable for use with Databricks. And now I'm going to go through the details in our microservice. So firstly, we built the ETL query pipeline in Databricks. We did the extract test in extract Databricks PY. So it automates the process of downloading the file food new CSV from the specific URL and uploading it to a Databricks file store. We then did the transform load task in the server mylib transform load Databricks PY. It takes the file food new CSV, transform it by adding unique IDs, and loads it into a Delta Lake table for further use in data analytics and other Spark-based data processing tasks. And lastly, we did the query test in the query food PY and query nutrition PY. So we queries the structure of the food table in a Databricks database. We process the column names and log both the query and its result for documentation. We also queried nutritional data from a Databricks database, and we log the queries and their outcomes for documentation. We can see logging result in the query log food and query log nutrition markdown file. Now I'm going to hand the task to my teammate Gavin to go over the Flux web application.
So to implement these functionalities, we use Flask to develop our server, and the server is defined in the server.py file, which is here. So there are two routings in the server. The first one is the index routing, which is visited when a user visits our index page. In the function, the service will first query the Databricks for all the nutrients to display in the drop-down menu, then put them into the drop-down menu in the index.html, and return the page to the user. And then is the query one routing, which is bounded with the query one function. And in this function, this routing will be visited when a user select a nutrient and click the submit button. And in the function, a query will be sent to the Databricks to retrieve 10 field and return that list to the user within the result.html file. And to make the web app's performance optimal, we set up a G-Unicorn web server to deal with the requests. And we have all the configurations for GUnicorn in the gunicorn.com.py file. And to deploy the website, we first pack our project into a Docker image. And the Docker file here contains all the packing instructions we have. And we use the Docker build command to pack the project and push it to the Docker Hub with the Docker push command. And then we go to Azure, create a web application, make sure to enter the correct Docker image tag and environment variables like access token, etc. in the configuration, and we have the website deployed. And next, Tina is going to continue talking about our GitHub actions.
Yeah, so in this project, we did the GitHub actions in our makefile and CI/CD YAML file. So the workflow includes running a makefile to perform tasks such as installation, testing, code formatting, and linting. So this automation streamlines the data analysis process and enhances our code quality. And here we have the GitHub code spaces dev container configuration as shown in this screenshot. And it's worth mentioning that we also effectively leverage key data engineering libraries such as PySpark and Databricks SQL. They helps us to streamline our Databricks ETL and query process. We use the mintf to set up the infrastructure as code. This file is a Terraform configuration script used for setting up infrastructure on Microsoft Azure using IAC principles.
In the end, we conducted load tests to test the stability for our web service. So originally, we want to test 10,000 requests per second. However, due to the code space limit, we can only send out about 600 requests per second. However, our web application performs pretty well. So according to the first graph, once the web server has been started, the response time has been pretty low and stable. So that means there's no lag for the requests, and also the failure rate has been pretty stable and pretty low for all the time. So it does not been disturbed by the number of requests. So that means our application is pretty stable under the load test. So this is all for our web service. However, there are some limitations and future works that we can conduct. So first, due to the limit, our service have limited in terms of personalized user engagement and versatility. So in the future, we can add personalized diet planning, nutritional advice, and also integration with health tracking applications to help our users better build up the health habits. And also we can incorporate predictive analytics and user behavior analytics to pave the way for more intuitive and responsive user interactions. So thanks for watching our demo video and hope you like our web service.